Good evening, everybody. It's been a while since I was at CocoaHeads. I think the last time I was at a CocoaHeads would have been June, probably, for WWDC. And the last time I presented, it's been a while. So when Marco asked me on Monday, would you be able to come join us for a presentation? I said, yes, Marco. I think I can do that. And then I did, and he's like, what's going to be your topic? And we talked about that a little bit. And then he published my presentation title, and he said it's going to be Concurrency of SwiftData. So, okay, maybe we should call this a story of miscommunication. Just to prove that, in Dutch, I said to him, I don't know what I'm going to talk about. It's going to be concurrency or SwiftData. He said, let's do that, concurrency or SwiftData. So yesterday I looked at the schedule, concurrency of SwiftData. It's like, okay, well, I guess I'm on the hook for that one. I know concurrency, I know SwiftData, I know all of these topics, so let's go for it. Concurrency of SwiftData, exploring SwiftData's concurrency APIs. So I wrote this talk this morning, because like I said, I had no idea what I was going to talk about. It's going to be either concurrency or SwiftData, but we can do both. It'll be fun. So before we get into concurrency and SwiftData, let's actually talk a little bit about SwiftData itself, because it's a core data wrapper, right? And that's not the same way that SwiftUI wraps UIKit, because Apple kind of hides that from us. They're like, yeah, it uses UIKit under the hood, but we reserve the right to rip that out at any point in time. For SwiftData, Apple actually says you can rely on the tried and tested powers of core data, right? So we can actually say SwiftData is for sure built on top of core data, and it was meant to be that way. And that kind of means that when we talk about SwiftData's model container object, we really mean NS persistent container. When we talk about a model context, we actually know that there's a backing NS managed object context. Model objects, they're NS managed objects, right? Of course, I can't prove the extent of how big or thin the wrapper is, but we know that they're under the hood, which means that we know a lot about how they're supposed to work. What's also fun is that a lot of our debugging still works, so that's great. We don't have to reinvent the wheel there. And of course, the best part, it also means that we're bound by the same threading rules we had in core data. They did not change that, they did not remove that, but they did do a little bit of a better job of hiding that, but more on that later. So if you don't know what model container, model context, model object are, that's not a big deal. We'll actually look at how we make a SwiftData model. A SwiftData model is a class. I know that a lot of people, when they talked about SwiftData 2-3 years ago, said, I hope it's going to be structs. It's not, it's classes. Why? Because NS managed objects are also classes. Simple. All we have to do to make something a SwiftData model object is apply the model macro to it. And that adds a whole lot of boilerplate code that I'm not going to expand here. If you really want to copy this code, go to Xcode, do expand macro, you'll see what it generates. It's more macros, it's a whole lot of stuff. It's really not that interesting. Also notice that I have this optional date here. If you've defined managed objects before, you know that almost everything was optional, simply because you wouldn't pass these arguments as initializer arguments, so Swift wanted them optional. They don't have to be. This one is actually optional because I wanted it to be optional, not because of some core data limitation. So that's nice. Next to models, we have our model container. The model container is similar to NS persistent container. It's basically your entry point, your main point of creating everything for your SwiftData container, right? So similar to core data. We can make one by calling the model container initializer and passing it the model classes that we want to use. In this case, it's just one. If there's multiple, it uses variadic generics, so you can just pass as many arguments as you want instead of an array of models, which is kind of cool. So if we've added our container to our view, which is typically how we use SwiftData, by the way. SwiftData, SwiftUI, they're best buddies. If you want to use SwiftData outside of SwiftUI, not best buddies. Okay, so if we have a view, we can grab a model context out of the environment. Again, it's very similar to core data. And here's the cool part. If we want to insert a model object into our store, we can make an instance of it, pass the arguments that we want to initialize this object with, which is kind of nice. However, just like before, we still have to associate our model objects with a context. If they're not part of a context, they will not be persisted. They will sort of be floating out there in space, not linked to anything. So in order for them to actually be persisted, we have to add them to our model context. And this is all we have to do. This is actually kind of nice. SwiftData models or model contexts can autosave. So after we've inserted something into a model context, shortly after we did that, it will automatically save and persist to your store. This might not be what you want. You can opt out of it. But if it is what you want, it's really kind of neat. You might even say it's amazing. But sorry. Usually by the end of the function scope-ish, but it also works with certain view lifecycle events and all that stuff. So Apple doesn't tell you when, but it's quick. All right, so this example that I just showed you is, of course, very, very simple. I just made an object, inserted, and I'm telling you it's amazing. Like, really, come on. Surely the bar for amazing is higher than that. And if we actually think about a typical iOS app or a typical app in general, we'll see that CRUD is a common pattern. If you're not familiar with it, it means create, inserting new data, read, fetching data from your store, update, modifying existing data, or delete, deleting existing data. Right? And if you think about pretty much any app that uses persistence in core data or SwiftData or Realm or whatever you like, these are probably 4 operations that you find very interesting. So if you want to implement this pattern in a core data app, right, kind of rewinding back to core data so we can better understand SwiftData, what I really love to do is have a single page for both creating and updating a model. I know that some people will have 2 SwiftUI views, one for create, one for edit. The create one inserts a new object, the other one updates an existing object. I like to have them both as a single view that I can just pass an object to and say, well, this one's new, this one's updating, but you don't know. You just know that you have a model object. Because actually, if you didn't know, managed objects are observable, which means that we can bind SwiftUI views to properties. So we can bind a text field directly to the title of a managed object. It's kind of neat. And to make this work beautifully, I like to use child contexts as a scratchpad. And this is kind of important because this, to me, is one of the things where I'm like, if SwiftUI can do this well, or SwiftData can do this well, it is truly amazing. But simply me saying that is kind of a spoiler. I won't say more than that for now. So what I like to do is if a user is editing a managed object and they decide, well, I made some changes, but I want to discard that, I just discard the entire context, which means that the entire set of changes is gone. For a new object, similarly, I added the new object to a child context. If I discard that, the new object is simply gone. If I persist, I'll actually save that into the view context, and now we have it everywhere. If you have trouble visualizing that, here's more or less what it could look like. In the middle, we have a managed object context, which would be used by SwiftUI view. So it drives a fetch request in core data and then populates a SwiftUI list. I also have a child context to which I can add new objects. And if that child context goes away, that new album also goes away. Similarly, if this was an existing one, changes to it would go away. Because all model objects, if you have one in a child context, you can have one in a list as well, right? So the view context can have an instance of, let's say, holy hell, and the child context can have its own version of that managed object, and it can change that in isolation. Even though it's classes, they're both separate instances that just happen to be created using the same underlying data. So knowing this, that I like child contexts, we can create them in core data. If you thought this would be complicated, it's really not. All we need to do to create a child context is this. Make a new instance of NS managed object context and give it a parent. In my case, it would be the view context, which is used for my SwiftUI views. And this will associate that context with the view context, the underlying store, and everything else. So we don't need to do anything special in core data to have a child context. It's really as simple as creating an instance and giving it a parent. So in SwiftData, however, we don't have this. Apple simply decided that child contexts and SwiftData are not going to be best buddies. We don't need them. We're not going to get them yet. Maybe next year, I hope. But for now, that's sort of where that story ends. So for doing CRUD and SwiftData, you're still going to have to do some workarounds and have your fields separate from your entities and all that. Not fun, Also not concurrency. So let's move on to doing work in the background. If we want to do core data work in the background, we also need to have a separate managed object context that we can create as follows. Still 2 lines of code, so that's also pretty straightforward. We can simply ask an NS persistent container for a new background managed object context. And again, this is just so you know where we're coming from. What are we wrapping with SwiftData, and how does SwiftData do this? So if we perform core data work in the background, why would we create that separate managed object context? Well, first of all, if we want to have an operation that runs off of the main thread and interact with core data, we have to have a managed object context that is compatible with this. If we use the view context, we must interact with core data on the main thread, because that's what the view context is hard linked to. It allows us to work with a managed object context without impacting UI. Imagine you're adding items one by one, you're generating them or whatever you're doing. It takes a while, so you're going to add maybe 100,000 records. You don't want your view to update every time you insert a new record. So having a background context is beautiful for this. You can do your work in the background, insert items, all of them, and at some point you're going to call save, and that's when your UI updates. Sadly, what it does not allow us to do, and something that I have seen people try in SwiftData, which was almost the reason that I actually just decided to roll with Marco's suggestive name for my talk. Some people want to fetch stuff in the background so that the fetch is not blocking, and then put all your objects on the UI. That's not what a background managed object context is for. Right? If we use a background managed object context, we're going to get objects that are tied to the background as well. We can't use them on the main thread. It's core data's threading model that we cannot break. It also doesn't allow us to update the database without impacting the UI at all. And what I mean by that is once we save our managed object context in the background, the view context is actually going to have to actively absorb what we just added, which still takes time. Right? So it's not possible to do that in a completely non-blocking way where the view context will just magically asynchronously get updates. We have to still do that on the main thread. So that's sort of background on backgrounding with core data. And if we think about core data context and threading, what's really important to know is that a managed object context can either run code on the main thread or on a private queue, where the private queue is managed by core data. We don't own it. We don't interact with it directly. This one's big. Managed objects are not thread safe. So keep that one in mind. We're going to talk about that a lot more in a bit. You must run core data code on the correct queue using perform or perform and wait. So if you want to use your background managed object context in the background, you're going to have to call perform on it to make sure that you're running on the correct queue. This is the worst. There's no compile time help. If you mess this up completely, the compiler will not tell you, hey, maybe you shouldn't be doing this on that queue, even when you're doing dispatch queue main and then interacting with your background managed objects. However, we can pass arguments to our schema for debugging. So we can tell our Xcode schema that, or our app schema, that we have to debug our code so that core data crashes whenever it detects a problem. By default, it will just happily chug along until it figures out that it couldn't, and then it will crash and it will look very weird. And if you're lucky, you'll get all that's left to us as honor as your crash message. So if we want to dispatch to the correct queue, we have to write code like this. Right, so this is a background managed object context, and we fetch a bunch of objects, we interact with them, we do work with them, which is fine. The top part is fine. And the bottom part would be a problem, right? Because we're dispatching to main and then we're using our background context. This would cause issues because we're not on the correct queue for this context. So back to SwiftData, because the rules have not changed. Right, we still have to be on the correct queue. The view context from SwiftData still has to be used on the main queue and all of that. So let's look at some Swift UI, concurrency, and SwiftData code. Who here thinks that this code should probably be fine? Nobody. One person? Right, well, if you already all know this, why don't you tell me? No, I'm kidding. This should cause problems indeed, because we're using a detached task, which means that we're going to be very explicitly not inheriting any main actorness. So we're going to be in the background and we're going to be making a sample model object. That on its own is fine, right? We're making the instance, we're not interacting with any contexts. and then we await model context.insert object. This should kind of be a problem because our model context belongs to the view, which means that it's main actor bound. For some reason, it doesn't crash, even when I enable concurrency debugging in core data. So SwiftData does something here. It very helpfully gives us a compile time warning. So it tells us you shouldn't be doing this, where I'm like, please make this an error if I shouldn't be doing this. But all of the sendable stuff with concurrency, in my opinion, could use a few more errors rather than warnings. So this could cause problems. It's actually telling us it's not safe because non-sendable type model context and implicitly asynchronous access to main actor isolated property model context cannot cross actor boundary. So in normal-ish English, that means that model context is not safe to be passed around between different threads, tasks, or actors. And since we were on the main actor before, and now we're very much not on the main actor, we shouldn't be grabbing model context from the main actor and pulling it in here. But the code doesn't crash necessarily. So what does this tell us, though, if we look at this? The model context is not sendable. In other words, we can't just pass it around across thread boundaries and task boundaries and expect it to work well. And this matches with core data's threading rules. So if we look at just that one warning, can we make that worse? Of course we can. Because we can also define our object outside of the task. So we are making our object on the main actor, and then we're going off of the main actor to add it into a model context that belongs to the main actor. And that gives us an error saying capture of object with non-sendable type sample model in a sendable closure. In other words, our object is not safe to be passed across concurrency boundaries. So model objects are not sendable, which is also the same as core data. So hopefully, with concurrency debugging enabled, this should crash our app. But again, it doesn't. Can this cause problems, though? Almost certainly, yes. But probably after you've ran your Xcode Cloud builds and shipped this off to production and had this out there for a while, and then on a Sunday you're going to get everybody crashing at the same time for this reason. I don't know why these kinds of crashes act like that. So can we catch this with a launch argument or something similar like we can with core data? For some reason, no. I don't know why SwiftData somehow manages to abstract this to just the level where I think is more dangerous even than what core data does by default, because we can no longer catch this problem. Also, I really wish that these warnings were compile time errors, because clearly this is telling me, hey, you are opening yourself up to data races right now, which are notoriously hard to reproduce, do on purpose, debug, and all that. But, you know, the compiler is just telling me about it. I hope in Swift 6 is going to be more of errors. But yeah, for now it's not. So at this point, we know that SwiftData leverages modern concurrency APIs. Otherwise, it wouldn't be complaining about sendable so much. But if we have that, how can we skip a little bit and do some work in the background? Because what we just saw was in a view, and I detached the task, and I was like, this should be on the main actor, but it's not, and it's not causing problems. But what if we actually wanted to go to the background and perform a whole bunch of work? I will start by making a background model context. I wish it looked like that. It doesn't. It's way more complicated. We have to write our own actor. And this actor is a model actor. And I'm pretty sure in beta 1, they didn't have the fancy model actor macro. They do now. So that's kind of nice because it saves us a lot of code. But that actor that we create here will act as our queue, essentially. So if we enhance that code snippet a little bit and expand the macro, because this one I think was a little bit interesting, here's kind of what it looks like. So at the top, we still have the function makeNewItem that inserts a new object into my model context. Then we have a non-isolated model executor, a non-isolated model container, and we have an initializer model container that takes a model container. And that then creates a model context, a model executor, and it assigns the model container to itself. There's also a computed or sort of protocol extension defined model context that we can access. So that's what I'm accessing right up top there in the model context.save. It's just a default property that I was given by the protocol. We don't see it here. So this would allow me to take this to the background and start running my make new item in the background. But let's talk about why this is an actor in the first place. Why do I have to create an actor myself to do work in the background? Why can't I make a context that I just call perform on? Well, first of all, calling perform on a context, that's very much core data style, right? We want to have this actor because that's what modern concurrency looked like. Because the model actor will internally synchronize all of its function calls and all access to model containers, model context, and everything into an executor. And an executor in an actor makes sure that all jobs that the actor is given, so all function calls, all property access, all of that, is run on the correct queue. It's how the main actor makes sure that everything we do on main is actually running on main. The executor is simply dispatching to the main thread every time. For SwiftData, the executor will dispatch to an appropriate queue, similar to how managedObjectContext.perform dispatches to an appropriate queue. So this actor essentially becomes an abstraction around perform and wait, and it gives us a compile time constraint, which is good, because now if we do things wrong, it's actually going to say you can't interact with this actor in this specific way, and that's actually an error. So how the model actor creates this executor, it's like this. There's a default serial model executor that SwiftData comes with. And what it really does is like a serial queue that will execute instructions one by one. So to use our custom actor, we maybe would like to try something like this, where we create our custom actor in our application and we make a custom model actor and we pass it a model container for our models, and then we say model context custom actor.model context, because a view needs a context. Luckily or unfortunately, depending on what you're trying to do, we cannot do this because the model context is isolated to this actor. So we would have to await this call in a task, which of course we cannot do in this body because the body is not async. So we can't just inject it. The container itself, as we just saw in the actor, would be non-isolated. But if we inject that, our view would actually take the model container's default model context, which would be main actor bound. So that would not work for us. The context is isolated, so we can't grab it in our view. And also it's not sendable. So even if we could somehow inject this into our view, we really shouldn't, because it belongs to the actor. So we should only interact with it inside of that actor and not make it past concurrency boundaries. In other words, we can't take it out of the actor onto a different task or different queue. So what we can actually do is we can create our actor on demand. So we can say let actor equals custom model actor inside of a button action. It's pretty lightweight to make this actor, and it's pretty lightweight to grab the model context container. So that's nice. And then we can make a task and we say await actor make new item. And that works. This compiles, this runs. And here's the real big question. Did that actually do something in the background? No, it did not. How about now? Does this do something in the background? Because now we're detaching to call actor.makeNewItem. Well, let's add a breakpoint and make new item and find out. No, we're still on the main thread. As you can see right up top there, thread number 1, custom model actor make new item. So this is not what we wanted. We just defined a custom actor. We used it. We did a bunch of weird things like making the actor inside of a button action, but it still doesn't work. So what's really happening here? We're not calling make new item from the main actor. We've used task.detached. So clearly it doesn't matter if we call from the main actor or not. Make new item is going to run on main anyway. We haven't annotated make new item with main actor, nor did we annotate it with non-isolated. Maybe those could have impacted this, but they're not there, so that's fine. We did not explicitly tie our actor's executor to the main actor. So the culprit, we created our actor from the main queue. So apparently a model actor's default executor will latch onto whatever context it was created in. So if we make our actor on the main thread, it's going to make its serial executor and say, oh, we're on main now, so probably you want to be on main all the time. So if we try this again, if we actually move that little bit of code down to make the custom model actor inside of our detached task, now all of a sudden we hit the breakpoint and we are in fact in the background, thread 5 in this case. right? So we can see that it matters where we make this actor. And luckily, making them is pretty lightweight. So in this case, if I want to do work on the background, I'm just going to make the actor right before I want to do the work. I'm going to call the functions on the actor that I have to call, and the work will be done in the background. Victory. So can we create our model object in the actor and then return it? That would be really cool, right? If we could just make the object in the background, return it, use it in our view. Sadly, not really. This code will compile just fine. There's no problem with this. We make our new model and we return it. However, when we try to do this, we're back in sendability hell. Because we're going to get some warnings saying non-sendable type sample model returned by call to actor isolated function cannot cross actor boundary. Right, so we shouldn't be doing that. And again, I really wish this was an error because it's clearly telling me what you're doing is dangerous. You're going to run into data races. It's going to be hard to debug, but it's just warning me. So with a custom actor, what can and what can't we do? First of all, it does not replace a child context, right? The child context in SwiftData does not exist. It can create background contexts, essentially, or sibling contexts, but never child contexts. It does replace a background context because we can run code off of the main thread, so that's nice. We cannot use our actor to populate a view, which, if you've done a lot with core data, makes total sense. But I've seen a couple people coming into SwiftData already thinking that all database operations should be in the background. So they are somewhat confused by this because these are warnings, not errors. So what's going on there? So we shouldn't, because the sendability warning is pretty clear. So that also means we can't use this actor as a repository. You might want to have something sitting in front of your database where you call functions, it returns results. We shouldn't be using our actor that way. So model actors should be completely self-contained in terms of the work that they do, right? So if you want to build like something that synchronizes your local Swift data store with a remote backend endpoint, your actor should receive your networking layer, make the API calls, insert your data, etc., etc. Or you can pass it the data you want to insert, whichever you would prefer. So in summary, SwiftData wraps core data, so it follows many of the same rules. Most of the things that I found out with concurrency and SwiftData that I showed you in these slides, it's all based on me knowing core data and me knowing Swift concurrency, going through the warnings, going through what's happening, observing what happens, and simply saying, oh, wait a second, this makes total sense because it works like that in core data. SwiftData just abstracted it good or poorly or very thinly, but there is an abstraction there. Model objects are not sendable, but the compiler only warns about that. So core data concurrency or SwiftData concurrency or core data concurrency debugging doesn't see these violations. Normally, if you do this wrong, your app will crash with a nice message, which is great. Somehow SwiftData works around this, which feels more dangerous to me because sendability warnings are telling me this is dangerous, but we no longer have a tool to make this more explicit. There's no wrapper for child context in SwiftData. If you really want it, by the way, there's still core data under the hood, right? So you could still grab managed object context and do a bunch of work. We have to make a custom model actor to have background contexts. Luckily, we have a macro for it, so that makes it relatively easy to do. We have to initialize our actor in the background to actually make it work in the background. That's a bit of a gotcha. If you do that wrong by accident, you're going to be running on main anyway. And apparently SwiftData relies heavily on sendability and actor isolation, and I think / hope that Swift 6 is going to give us a lot more errors rather than very subtle warnings. So thank you. Thank you, Marco, for giving me an amazing talk title to work from. If you like this talk, you want to learn more about concurrency, core data, or combine, and probably in the future SwiftData, I have a whole bundle with these books. Go check that out. And yeah. Back to the thank you slide. And of course, if we have questions, I'll happily take them. Yes.
I haven't really looked into SwiftData, but does SwiftData need merging? For example, can I just make a detached task, make the actor, insert the item in there, and then pass along the ID from the actor, basically, and just immediately fetch it from the model context of that view after that task? Is that possible, or is there still merging going on with these sibling context actors?
Yeah. So the question is, does SwiftData still do merging like core data does? So basically, if you insert something in the background, can you get the persistent object ID, pass that back to the view, fetch your new object based on the persistent object ID without any merging going on?
Yes.
It works the exact same way as it does in core data.
Adding to that, the merging happens immediately.
The merging happens immediately, yes, because it's set to automatically merge changes from parent by default. Right, so it's identical to core data in that regard.
Okay.
Any other questions? It sounds like everybody is very excited for Beta Bala, which I've just seen from the corner of my eye. I've entered the room, so thanks everybody.